All right, all set up, ready for another video. Hi everybody, welcome. My name is Tundra. This is my project. Today we're playing around with some new stuff. I'm doing a trebuchet today. Yeah, a trebuchet. That's crazy. All right, but before we get to that, let's start off with some of the simpler stuff. I've been playing around with this idea of like a force redirector. Kind of acts like a pulley, but it doesn't necessarily need like real rope. So here I've got like these little. It's like virtual rope, but in reality, there's really nothing there at all. It's just forces are being measured between um, these objects to make it so that the length of rope here is essentially constant. And if it gets stretched out, then forces are applied to all the different objects to try to keep that force, try to keep that distance the same. So it acts kind of like a pulley, but it's not really a pulley. But it's kind of like a pulley. But it allows you to do force redirection basically in any direction without any issues. And it's, like I said, a PD controller that keeps the length of rope the same. So we can use that like in this setup with a fixed pulley and then two weights, or we can use it more like this setup where we've got the two fixed weights and then we've got like a moving pulley in the middle, or some combination of those different things. In fact, we can kind of like we did in the pulley video where we chained a bunch of, made a big pulley block to chain a bunch together and have a big mechanical advantage. We can do that with this system as well. And so we've got the ability to use, this is like I think what, a 9-to-1 mechanical advantage. Oh, you can't see it because the camera's on me. Let me put that there and that there. And then I can basically pull on this and lift this 200 kilogram block essentially with one hand because of the mechanical advantage on it, which is pretty cool. All right, so we've got all these new tools to play with. We've got real rope, we've got like these virtual ropes, we've got real pulleys and virtual pulleys. And let's make a trebuchet out of this stuff. How about? All right. So we are going to need one more thing, and that is, so here's the trebuchet if you can see it. It's massive. It's like so big. That's crazy. Um, it's not as big as like a real medieval trebuchet that like throws like, you know, 200-pound blocks of stone and stuff like that. It's not quite that big. This one is optimized to throw basically bowling balls. So instead of 200 pounds, we're throwing 16 pounds. And so it's scaled down accordingly for that. Also, I'm able to load this, I'm able to get this all set up with just one person. And that's kind of another difference between this and a big monster trebuchet. So to do that, we are going to need a lot of mechanical advantage. In this case, I don't think the pulley block is going to work all that well for us. So I created this gearing system here. This is a speed reducing gearbox. I've got on the little gears, we've got like 12 teeth. On the big gears, we've got over 40 teeth. And so that's going to make this, when you add it all up, you end up with, it's probably like a 50-to-1 ratio. So these teeth are just tiny little spheres, so they collide extremely well with each other. It's not real heavy or anything like that. And they're super stable, and it works pretty awesome. Okay, and I've got this little what do you call it? This little ratchet that catches it so that it only turns one way and then it locks, which is pretty slick. Okay, so we've got our gearing system. Oh, by the way, I also built a motor. So I don't have to turn this thing by myself for the next 20 minutes and make you guys watch that. So I've got a motor to do a little bit faster. So you'll thank me for that in a minute. Okay, let's get this set up. Let me grab the real rope. Let's do camera on me. Okay, so I've got this set of real rope here because it's preferable for some stuff, right? So like virtual rope is good. in some cases, but real rope is better in other cases. And we're just going to use it all. So I'm going to set this up, feed it through this lower pulley here, and then attach it. I've got like a spool over there to take up the rope. And we'll use this rope to pull down the big lever arm that we're going to use to transfer energy from the giant counterweight to the bowling ball, right? So the counterweight itself is like, it's huge. It's like 1,000 kilograms. I can barely move it. Like if I try to push it, my character's body weight does almost nothing to this thing. Um, so it's pretty crazy just how big this is and difficult to move. But yeah, to be able to get this stone lifted up into the air so that we can drop it and put force into the bowling ball, there's no way that my character could do that without a significant amount of mechanical advantage. So we're going to run this thing through the gearbox and get it all hooked up, and then we'll be able to do it. All right. I've still got my 6 degrees of freedom rig set up. So I'm tripping all over the place and getting twisted and going sideways. It's pretty annoying. But we'll get that resolved in a future video where I've got like ground control fixed and everything. In the meantime, it is what it is. All right, so I've got that wedged in there. And to show you that I can pick this thing up, we'll give it a few spins. So here, let's tighten it up a little bit so you don't have to watch me do that. We'll use the motor. So here you go. All right, so we're starting to get a little bit of tension on the rope. And you can see the lever arms starting to move, the bowling balls starting to come down a little bit. So we've got this hooked up to another pulley system up there. Another pulley system up there that that makes it so that's a quick release, and the rope's going to pull the lever arm down, and then the quick release pops loose, and then away it goes. So to reset it, you have to get up there and reset the rope to the quick release. And so if it's on a pulley like that, then it makes it easier to climb up there and get to that low point where the rope can be reattached. And then as it's pulling down, it moves outward and makes it so that you've got, as you keep lifting this thing, you've got better and better leverage as this slides out towards the end. So that's nice. Okay, here, let me show you that, like I said, that I can indeed do this under my own power. So I'll put this back on me, and I'll give this a few cranks. And again, I can just do this with one hand. I think the weight, so like I said, the counterweight is 1,000 kilograms. The arm itself is 200 kilograms. And the length of the lever arm is probably, it's around a 4-to-1 ratio, 4-to-1 to 5-to-1. And so the amount of the force that I have to pull down on this to get this lever arm to come down is probably roughly, I don't know, 300 plus pounds or something like that. So there's no way that I could do that without this mechanical advantage. All right, let's turn the rope back on, the motor back on, and finish off this. So as you can see, we're getting close Getting close to the bottom here. It's almost in position. The weight in the back is actually quite high now, nearing the top of where we want it to be. And so I'll let this thing get nice and close to the bottom, and then I'll shut down the motor. And it's pretty much ready to go. So let me get the bowling ball out of here and set it up. So it goes into this little channel. All right, that's about as far as it goes. So the ball is connected to the lever arm. Right now it's just, normally you use a sling to do that. But I didn't want to use real rope for that, because the real rope that I have to do is to make it stable. It has to be pretty heavy. It's overly heavy and overly stretchy. So I used a regular joint with a linear limit, and then I'll, like the quick release that's on the rope down here, I'll have another quick release that releases the ball when it gets in its arc at the right angle, right? So essentially the big counterweight so I'll pull the quick release over here, the big counterweight will drop, the arm will go flying up into the air, the ball will get pulled in a big arc and whip around, and then when it gets at the right angle, I'll hit the other quick release and the ball will go off like into orbit, basically. All right, so we're taking all of the potential energy of this 1,000-kilogram object. We're dropping this and trying to put all that potential energy into kinetic energy on this like 6-kilogram bowling ball. So it's a crazy amount of energy transfer that goes into that and just launches it. So let me try to set the camera up in a place where you can see like the whole thing. So let me back this up and then aim it like down here, I guess. So this thing is really tall though. So it's going to be hard to get the whole arm and everything in the shot. Let me put the camera like way up in the air. Maybe that'll help. And do that. What do we think? Is that going to work? I don't even know if I can set the camera up very well for that. Let's see. Well, now you can't really see. This is a tricky shot to get. Okay, so yeah, that's not too bad. That's not too bad because you can see the little sign that has the distance and the height and the velocity of the projectile, and you should be able to see most of the flight path and everything. All right, so with that, I think we're ready to go. We'll just count down, and 3, 2, 1, launch. Oy. So we're doing like 50 meters per second. It looks like it did about 320 before it crossed the ground. So about 320 meters of travel. That's pretty good. All right, so that's pretty much it. Let me know what you guys think. That's pretty crazy. It's a fun tool. I really enjoyed making it, and let me know if you have any questions, comments, and we'll see you in the next one. Take care.